Hello, I'm William Michael of the Classical Liberal Arts Academy, and in this video we're going to continue our study of the Academy's Modern Arithmetic 4 course, getting into our third lesson. And in this lesson we're going to cover articles 40 through 50 in Ray's Higher Arithmetic. So at this point you should have completed the first two lessons. You should have memorized the definitions that are in those first two lessons, and you should be all ready now for articles 40 through 50. If you haven't done that work yet, take your time and go back and do it. Don't try to rush on before you've mastered the content, because we're going to keep building on that knowledge and we're going to take it for granted that you know those things and that you know them accurately. So don't try to rush ahead, or you'll just end up confused and you'll need to go all the way back to the beginning and start over again. It's much easier to get it right the first time than to try to rush, run into trouble, and just have to go back anyway later on to get it done. So we're going to pick up at Article 40. The purpose of these lessons, this is very simple study. You just have to read, and a lot of it's memorization work, a couple concepts that you need to really wrap your mind around, but it's simple study. My goal in these opening lessons is to go through and make sure that you know how to pronounce all the words, help you just get through the text the first time, and prepare you so that you can then take your time and go through and study it on your own time. So let's read through articles 40 through 50 together. I'll make comments wherever I think they might be helpful, and then you can get to work with these studies. All right, so let's take a look at the text. Picking up here at article number 40 up top, we learn that there are two operations, two of the fundamental operations of arithmetic that we're going to learn here in article 40. First, numeration, and then notation. Numeration is the method of reading numbers. Numeration is the method of reading numbers, and notation is the method of writing numbers. So make sure you understand the difference between numeration, the method of reading numbers, and notation, the method of writing numbers. Numeration, reading, and notation, writing. Numbers, we read there in Article 40, can be expressed in three different ways: by words, that is by writing out the names of numbers, by letters, and by figures. By words, by letters, and by figures. Article 41. The first 9 numbers are each represented by a single figure. Now, what's important to understand here is this textbook is teaching us, let me flip over to the camera for a minute. This textbook is going to show us that there are two important different systems of notation that are used in arithmetic. The first is what's called Arabic notation, and that's what we're going to learn here in these next 8 or 9 articles. And then in Article 50, we're going to learn about Roman notation. And it's important for us to learn both of these systems of notation because they're both used in modern writing. So the first, like I said, 8 or 9 articles deals with Arabic notation, which is our normal system of reading and writing numbers. And then Article 50 is going to walk us through the rules of Roman notation. All right, so we're going to learn two different systems with Roman notation coming in Article 50. Let's get back to the text. Article 41, the first 9 numbers are represented by a single figure in Arabic notation, like this. And we have the first 9, really the only 9 figures for numbers that are used in Arabic notation, the numbers 1 through 9. And we see here the figures that are used to represent these numbers, and also the words or the names of these numbers. All right? All other numbers are represented by combinations of these and another figure that is called 0 or naught or cipher. So in order to write any number in Arabic notation, the real genius of Arabic notation is that we only need to learn 10 figures to express any number in our language. Though there may be an infinite number of numbers, infinite number of names of numbers, we can express any number using only 10 figures. And that's really amazing. Think of, in grammar, we use 26 letters in English, 26 letters to compose all of the different words and sentences that we use to communicate in English. 26 letters. In arithmetic, the Arabic system of notation requires us to use only 10 different figures. That's really amazing, and that's one of the benefits of the Arabic system. Even more easy and simpler than Roman notation, we can express any number with only 10 figures. So let's get back and continue studying Arabic notation. All that we need to know to express Arabic notation are these 9 figures and one more, the figure 0. So there are 10 figures in all, 1 through 9 and 0. Those are the only figures needed to express numbers using the Arabic system of notation. And note this remark here, the cipher or 0 is used to indicate no value. The other figures are called significant figures because they indicate some value. Significant figures indicate some value. You'll need to remember the meaning of this term significant figures when you study modern science, especially physics class. When you study physics and some chemistry, you're going to need to do some work in arithmetic and algebra, and you're going to come up with this phrase significant figures in your science classes. Make sure you remember you studied it or learned about it back in arithmetic 4, okay? The cipher or 0 is used to indicate no value. The other figures that indicate value are called significant figures because they indicate some value. Article 42. Once we go higher than 9, and again, I know this is review, but it's good for us to just pay attention to the method by which we communicate in arithmetic and appreciate it. The number higher than 9 is named 10, and it is written with 2 figures, 1 and 0. In this number, the cipher or 0 merely serves to show that the unit 1 on its left is different from the unit 1 standing alone, which represents a single thing, while this number 10 represents a single group of 10 things, or 110. The 9 numbers succeeding the number 10 are written and named as follows. And we see that each of these numbers is written with a 1 in the tens place, followed by increasing numbers in the units place. The number 11 has a 1 in the tens place and a 1 in the units place. The number 12 has a 1 in the tens place and 2 in the units place. And it goes on like that through 19, where we see 1 in the tens place and 9 in the units place, 11 through 19. In each of these, the one on the left of the number represents a group of 10 things, while the figure on the right expresses the number of units or single things in addition to that group of 10 things, which are required to make up the number. You don't have to pay any attention to that remark on the bottom of the page. It's simply a note about the history of the language here. So make sure you understand that the way that Arabic notation communicates or expresses numbers greater than 9 is by using different places in the number. We place a 1 in the second place to the left, and that indicates one group of 10 plus the number of units that are written on the right. We use 2 places to express numbers greater than 9 in Arabic notation. Let's move on here. The next number above 19, which is 9 and 10, is 10 and 10, or 2 groups of 10, written 2, 0, and called 20. We can see that once we go above 19, we now have 2 full groups of 10. We write the 2 in the tens place, and there are no units left over. This is how we express the number 20, 1 greater than 19. The next numbers are then 21, 22, and so on, where we have 2 groups of 10 and increasing numbers of units to make up those numbers. We then move up to 3 tens, which is called 30, 4 tens, which is called 40, 5 tens, which is called 50, 6 tens, which is 60, 7 tens or 70, 8 tens or 80, and 9 tens or 90. The highest number that can be written with 2 figures is 99, meaning that we have 9 groups of 10 and 9 more units left over. If we have 1 more unit added to that number, we will then have 3, we will actually have 10 groups of 10, and we'll need 3 places to express that number. The next higher number is 9 tens and 10, or 10 tens, which is called 100 and written with 3 figures, 100. This shows us that we have 1 group of 100, 0 tens and 0 units. The 2 ciphers or zeros show that the unit on their left is neither a single thing nor a group of 10 things, but a group of 10 tens, being a unit of a higher order than either of those already known. In like manner, we have 200 and 300 and so on, and these express 200s, 300s, and so on, all the way up to 10 hundreds, which is called 1,000, and is written with 4 figures, 1, 0, 0, 0. We see 1,000, 0 hundreds, 0 tens, and 0 units. That's 1,000. And all of that is in Article 42. I'm reading through this quite quickly, but I assume that you're familiar with most of this information already. If not, just take your time and you can listen to this again or just read through the text yourself. But I assume that most students are probably pretty comfortable with this information. Article 43. The order of a figure, the order of a figure is the place it occupies in a number. And remember, this is the method by which numbers are expressed in Arabic notation. Arabic notation uses different orders to allow any number to be expressed using only 10 different figures. It does so by placing those figures in different orders. The order of a figure is the place it occupies in a number. From what has been said, it is clear that a figure in the first place, with no others to the right of it, expresses units or single things. But standing on the left of another figure, that is, in the second place, it expresses groups of tens. Standing at the left of two figures in the third place, it expresses tens of tens or hundreds. And in the fourth place, it expresses tens of hundreds or thousands. Hence, counting from the right hand, the order of units is the first place, as we see in the number 1. The order of tens is in the second place, as we see in the number 10. The order of hundreds is in the third place, which we can see with the number 1 written in the third place to the left, which is 100. And lastly, the order of thousands, which is in the fourth place, as we see in the number 1000. By this arrangement, the same figure, 1, has different values according to the place or order in which it stands. The same figure is used to express different values based on what place it stands in, or what order it stands in. Thus, 3 in the first place is 3 units. 3 in the second place would be 3 tens. And 3 in the third place would be 3 hundreds, and so on. That's Article 43, explaining the use of order in the Arabic system of notation. Moving on to Article 44. The word units may be used in naming all the orders as follows. Simple units are called units of the first order. Tens are called units of the second order. Hundreds are called units of the third order, and thousands are called units of the fourth order. And it goes on higher into higher orders, as we'll see below. Article 45. The following table shows the place and name of each order all the way up to the 15th order in Arabic notation. And many of these numbers you'll never use, but it's important for us to at least know where we can find the names of the different orders all the way up to hundreds of trillions, which is the 15th order. So in this table of orders, if we go all the way over to the right-hand side, we see the first order is units, the second order is tens, the third order is hundreds, the fourth order is thousands, the fifth order is tens of thousands, the sixth order is hundreds of thousands, the seventh order is millions, then tens of millions, then hundreds of millions. The 10th order is billions, then tens of billions, then hundreds of billions. The 13th order is trillions, and then tens of trillions and hundreds of trillions. These are the names of the first 15 orders in Arabic notation. Article 46. For convenience, so this is not necessary. Article 46 is telling us that this is simply a matter of convenience, a way to make reading and writing numbers easier. Article 46. For convenience in reading and writing numbers, orders are divided into groups of 3. Orders are divided into groups of 3, and this is just for convenience in reading and writing numbers. Each group of 3 orders is called a period. Each group of 3 orders is called a period. And periods are used just for convenience. They're not necessary, but it makes it easier for us to read and write larger numbers. The following table shows the grouping of the first 15 orders into 5 periods, 5 groups of 3 orders. So the first 3 orders, units, tens, and hundreds, are grouped together, and they're called the period of units. The second period is for thousands, tens of thousands, and hundreds of thousands, and that's called the second period. Then we have millions, tens of millions, and hundreds of millions, called the third period. We then have billions, tens of billions, and hundreds of billions in the fourth period. And lastly, trillions, tens of trillions, and hundreds of trillions in the fifth period. So 15 orders in Arabic notation, and there are many more. This goes on forever. But we learn of the first 15 orders in Arabic notation, and we learn that these 15 orders are grouped into groups of 3, and each of these groups of 3 is called a period. And when we write larger numbers, we use a comma to mark the different periods in a number, and that makes reading and writing numbers much easier. In some other countries, they use a period to mark a period, which seems like it would make more sense, but in America, we use commas. Article 47. It will be observed that each period is composed of units, tens, and hundreds of the same denomination. Units, tens, and hundreds of the same denomination. So let's look back up at this. If we look at each of the 5 periods, the first period, the second period, the third period, the fourth period, and the fifth period, we'll see that each period contains units, tens, and hundreds. Units, tens, and hundreds. Units, tens, and hundreds, and so on, of different denominations. Here of units, here of thousands, here of millions, of billions, and of trillions. So 5 different denominations, but each period is broken into units, tens, and hundreds of that denomination. That's what's explained here in Article 47. Article 48, a list of the periods, so the groups of 3 orders, a list of the periods according to the common or French method of numeration. And so this is just for reference. We're really never going to use these numbers in any of our arithmetic studies, but it's just put here for the sake of reference. And that goes all the way down through 22 or so, or 20 different periods. I guess it's 22 different periods. They're listed in Article 48, just for the sake of reference. So let's look down here to principles. Principles. And these principles sort of draw together all that we've learned and summarize it for us as principles, or first propositions, primary truths, as we learned in our first lesson. So let's look at these 3 principles. Principle number 1, 10 units of any order always makes 1 of the next higher order. 10 units of any order always makes 1 of the next higher order. Principle 2, removing a significant figure 1 place to the left increases its value tenfold. Removing a significant figure 1 place to the left increases its value tenfold. And removing a significant figure 1 place to the right decreases its value tenfold. It's important to explain here what removing means, because in modern use, when we use the word remove, we mean to get rid of something, like to remove stains from your clothes means to get rid of them. That's not what removing means here, and it's going to make this principle confusing if you don't understand. Removing here just means moving. It just means moving. So moving a significant figure 1 place to the left increases the value of that figure tenfold. If we have a 1 in the units place and we move that 1 place to the left, we increase the value of that number by 10 times, or tenfold. If we move it from the tens place 1 order to the left, we again increase it by 10 times, making it equal to 100. So removing a significant figure 1 place to the left means moving a significant figure 1 place to the left. And in the same way, moving a significant figure 1 place to the right from the hundreds to the tens decreases the value of that figure by a division of 10. And the same is true if we move from tens down to units. So make sure in principle number 2, the word remove doesn't confuse you. It doesn't mean we're taking it away and getting rid of it. It means we're simply moving it in different orders, in different directions. And then lastly, principle number 3, vacant orders, that means empty orders, orders that have no significant figures, are filled with ciphers or zeros. Vacant orders, empty orders, are filled with ciphers. Okay, those are the three principles of the Arabic system of notation, and that's very important. 3 principles of the Arabic system of notation. Under those principles, we see here a problem. We're given a great number written with a number of figures here, and we're asked to express in words the number which is represented. So write the name using words of this number which is represented here in figures. Now you can see here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 orders in this number. We have 9 orders in this number, and they're not broken or divided into periods. They're not separated into groups of 3. And you can see how difficult it is to read a number when it's not divided into periods. That's why the use of periods is convenient. It makes reading and writing numbers easier for us. We can look down here and see the solution, and the first step of the solution is to divide the number into periods to make it easier to read. The number divided into periods, we have 608 followed by a mark that signifies a period. Normally this would just be a comma. Then 921 and 045. So you can see here when the number is divided into periods, it's much easier to read. We then read the answer to the problem, the solution, which is 608 million. The third period is the millions period. 608 million. The second period is the thousands period, and we have 921 thousands. And then we have the units period. We have 45 units. 608,921,045. So you can see how taking a great number and dividing it into periods makes it much easier for us to read that number if we know the different periods and their names, or denominations, I should say. Okay, so we have 3 principles of Arabic notation, and we're given one problem that shows us how dividing the number into periods makes it easy for us to read and to write. We then have a rule for numeration, and remember, numeration is the method of reading numbers. A rule for numeration, or a rule for reading numbers. Step 1, begin at the right. Begin at the right. Begin at the units place. Begin at the right and point or mark the number into periods of 3 figures each. So starting on the right, count 3 orders and place a mark to show the period. That's step number 1. And continue that to the left all the way through the number. And then rule number 2, or step number 2 of the rule, commence or begin at the left and read each period with its name. So there are 2 steps for reading numbers in Arabic notation. First, mark the periods of the number, starting from the right and moving to the left, and then read the names of the periods, starting from the left and moving to the right. And you see an example of how this is done in the solution to that problem. That's the rule for numeration, or the rule for how to read Arabic numerals. Okay, moving on, and you have a bunch of examples here which you can work on in your exercises. We'll move past that here and get down to a rule for notation. Remember that notation is the method for writing Arabic numerals. Notation is the method of writing numbers. The rule for notation is to begin at the left, write each period in its proper place, filling the vacant orders with ciphers. So knowing the number, knowing the name of the number, when we have to write that number using figures, we start at the left, write each period in its proper place, and fill any vacant orders with zeros. That's the rule for notation. And then you see examples in notation, which you're to work through in your exercises. Okay, but there's the rule for notation. That brings us down to Article 49, which is the English method of numeration. Article 49, in the English method of numeration, 6 figures make a period. So remember, before we learned 3 orders make a period. That was called the French method. Here we're learning the English method of numeration, where 6 figures make a period. The first period is called the units, then the millions, then the billions, then the trillions, and so on. And we have an illustration here of the English method of reading numbers, which divides numbers into periods of 6 different orders. By this system, the 12 figures at the right are read 210,987,654,321. By the French method, they would be read 210,987,654,321. So we learn a different method of numeration here, the English method, in Article 49. And lastly, in Article 50, we learn the Roman notation, the Roman method of writing numbers, the Roman notation, Article 50. And we have a quick overview here of how to express numbers using Roman notation, which is very helpful. Not necessarily in arithmetic class, because we don't use Roman notation in writing arithmetic, but we use it often in other areas of our study when we're writing, making lists, and things like that. So it's important to learn the Roman notation. Let's just read through the different principles here of the Roman notation. In the Roman notation, numbers are not represented by 10 figures like Arabic notation. Numbers are represented by 7 letters. Numbers are represented by 7 letters. We learned that there are 3 different ways to express numbers, one by words, one by letters, and one by figures. We saw that in Arabic notation we use figures. Here in Roman notation, we see that we use 7 letters to represent numbers, to express numbers. The letter I represents 1. The letter V, or actually it's a U in Roman or Latin, represents 5. X represents 10. L for 50. C for 100. D for 500. And M for 1,000. This is going to need to be memorized for your lesson, so you're simply going to need to recite it until it's memorized. The letter I represents 1, V represents 5, X represents 10, L is 50, C is 100, D is 500, and M is 1,000. Of those letters, the two that I often used to get confused when I was first learning Roman notation were L and D. So make sure you pay attention to L and D. L is 50 and D is 500. Don't let them be confusing. The other numbers are represented according to these 5 principles. First principle, every time a letter is repeated, its value is repeated. Thus, 2 I's denotes the value 2, or 2 times 1. 2 X's denotes 20. So there's no order, there's no place value in Roman notation. When numbers are written side by side, their value is repeated. We're not increasing the value tenfold when we move to the left as we do in Arabic notation. The simple value of that letter is repeated. That's the first principle of Roman notation. Second, where a letter of less value is placed before or to the left of a letter of greater value, the less on the left is taken away from the greater on the right. So if we see IV, we see the letter I, which represents 1, placed before the letter V, which represents 5. A lesser number is placed to the left of a greater number. That means that that value is to be taken away from the greater value. So IV is equal to 4. 1 taken from 5. The third principle, where a letter of less value is placed after one of greater value, the less is added to the greater. So if the letter I, which represents 1, is placed after or to the right of a greater number, a greater letter of value, it's added to that greater value. So X represents 10, I represents 1. Here, because the I comes after the X, it's added to the value of the X, making XI 11. If the I was placed on the other side of the X, it would be taken away from the 10, and IX would be equal to 9. The fourth principle of Roman notation, where a letter of less value stands between 2 letters of greater value, it is taken away from the following letter. So here we see the letter X, which represents 10, and the letter V, which represents 5, and in between them we have the letter I, which represents 1. Should we add 1 to 10, or should we subtract 1 from 5? This fourth principle tells us that when this happens, that lesser letter in the middle should be taken away from the letter that follows it. So this 1 will not be added to 10. This 1 will be taken away from 5. So XIV means 10 and 1 from 5, which is 4. 10 and 4 makes 14. And lastly, a bar placed over a letter in Roman notation increases its value 1,000 times. A bar placed over a letter increases the value of that letter 1,000 times. So if we have the letter V, which represents 5, and we have a bar placed above the V, that means 5,000. 5,000. Here we have the letter M, which represents 1,000, with the bar above it. That means 1,000 times 1,000, which is 1,000,000. So the bar multiplies the value of the letter by 1,000. Those are the 5 principles for Roman notation. And then to finish the lesson here, to finish up Article 50, we have a table that shows us the Roman numbers written in Roman notation, which is just a helpful reference. And you should study these principles in order to learn how to express any number in Roman notation. And that brings us to the end of this third lesson. Now, I know there was a lot of information in that lesson, and it's a very important lesson. Hopefully, though, and I think in most cases for most students, you'll already know most of the content of this lesson, especially if you've studied Modern Arithmetic 3 in the Classical Liberal Arts Academy. So for many of you, this may just be review. If all of this is new to you, you just need to take your time and study through the lesson carefully. It's only 10 articles. There are 10 very important articles, and there's a lot of information packed into these 10 articles. But just take your time. Work through Lesson 3 carefully. Make sure every single point is clearly understood, because you're trying to build a strong foundation for your study in arithmetic. And as I say in these lessons, many students try to rush through these first lessons, and later on they get into trouble. And the reason why they struggle in mathematics is because they didn't learn these simple lessons. Don't make that mistake. Take your time, build a strong foundation, and make sure you master all of these definitions and principles learned in the beginning of arithmetic. You have a lot of study to do, especially if this is new material for you. If there's anything in here that you'd like to talk about or that you need help with, just get in touch. I'd be happy to help you. God bless your studies.